All right, so example 5 on section 3.5, we're going to be writing a polynomial equation. We know all the answers, and our task is to write the polynomial function simplified that makes this. So if you recall, the number of answers tells you what power it should be. So 3 answers means there's a third power, so we should have x to the third, x squared, x constant. And we need to construct this polynomial based on the answers. So first off, if the roots are 9, 1, and negative 2, I'm going to write a few things on here you don't have to do. I just want you to see where things are coming from. So I'm going to say don't write until I tell you to start writing, because what I'm about to write here is not necessary ever, but I need you to see where things are coming from. So if x equals 9 is a root, and x equals 1 is a root, and x equals negative 2 is a root, thinking back to the zero product property, that means that x minus 9 should equal 0 if I move the 9 back over there. And x minus 1 should equal 0 if I move the 1 back over there. And x plus 2 should equal 0 if I move the 2 back over there. And if I have things equal to 0, that represents what the factors would have been. So what I'd write if I were you when I see the answers, I'm going to write p of x equals, I'm going to write this factor times this factor times this factor. Okay. The end result, going from there directly to here, is you said to do x minus each answer. So if 9 is an answer, x minus 9 is a root. If 1 is an answer, x minus 1 is a factor. Sorry, I said root. 9 is a factor, x minus, or sorry, 9 is a root, x minus 9 is a factor. 1's a root, x minus 1's a factor. Negative 2, so x minus negative 2, better known as x plus 2, is a factor. So again, be able to go from there to here. Again, this stuff isn't necessary to do that, if you make the connection. All right. X minus root times x minus root times x minus root. There's 3 roots, there's 3 factors. My task now is to, that's the answer, now I need to simplify and get it down to the form I'm looking for, which is a simplified cubic function. Something x cubed, something x squared, something x constant. All right? This is a binomial times a binomial times a binomial, so the first multiplication of any 2 of these binomials is going to be by FOIL. It doesn't matter which 2. Does anybody have a preference?
Can't you take x times everything and then 9?
Well, I've got to do 2 of these together first and then multiply by the other one. So I have to do that. So do you want to do black times blue, blue times red, black times red? Doesn't matter to me.
Black and blue.
Black and blue. Okay, so we'll do the brews first. All right. Black and blue brews. Here we go. X minus 9 times x minus 1. So if I FOIL this, x times x makes x squared. X times minus 1 makes minus 1x. Minus 9 times x makes minus 9x. And last times last, negative 9 and negative 1 makes positive 9. Okay. Now, yes, write all this stuff down. So this is FOIL. Again, the FOIL we've done quite a bit. All right. And notice I've multiplied all this out, but I keep it in parentheses because this product still needs to be multiplied by x plus 2. And this is still p of x equals. Okay? So first times first, 2 positives make a positive, outside, outside, opposite signs make a negative, inside, inside, opposite signs make a negative, last times last, same signs make a positive. Products are what they are. Letter times letter add the powers, number times letter stick them together, get the correct signs on each object. Then I'm going to simplify by adding like terms. Notice I have x squared, I've got minus 1x and minus 9x, and I've got plus 9. All right, so as far as like terms are concerned, I'm going to have x squared minus 10x plus 9.
Is this where we take x times it all and then x 2 times it all?
Yeah. So can everybody see that this part factors to that, x squared minus 10x plus 9? Okay. Now we're multiplying this times x plus 2. We have 2 options. The way I've got it drawn up here, I'm going to do it the way where I multiply this times both of these, this times both of these, this times both of these. You can also do x times all 3 of these, 2 times all 3. It doesn't matter which order you go in. just pick a choice and go with that. So I'm going to do it this way. So every object in this multiplies by every object in that. That's how you multiply a trinomial times a binomial. So if I do x squared times both of these things, x squared times x makes x cubed, x squared times positive 2 makes positive 2x squared. Then I'm going to multiply negative 10x. It's negative 10x, it's not just 10x, the minus sign's attached to it. Pay attention to detail. This is a place where people tend to mess up. Not paying close attention to detail of signs. So negative 10x times positive x makes negative 10x squared. Negative 10x times 2 makes negative 20x. Then I multiply 9 times everything. Positive 9 times x is positive 9x. Positive 9 times 2 is positive 18. So the green objects I got by multiplying x squared times this binomial. The blue objects, negative 10x times this binomial. The black objects, net positive 9 times that binomial. Again, the other option was to take x times all three things. That would have made x cubed, negative 10x squared, and positive 9x. Positive 2 times everything would have made positive 2x squared, negative 20x, and positive 18. You get the same products, just in a different order. The order doesn't really matter, so whichever one you do is fine. But again, that's how you do your second multiplication. Every part of one multiplies by every part of the other. And then once again, you look at like terms. So my final step here is combine like terms. 2x squared and minus 10x squared are like terms. Negative 20x and positive 9x are like terms. X cubed and 18 have no like terms. So my final step is to combine those like terms. And again, I have to make decisions about add or subtract and what the sign should be. I add if the signs are the same. I subtract if the signs are different. The sign matches the bigger number every time. So x cubed. These are different, so I subtract 8x squared, 10 is bigger, so it's negative. These are different, so I subtract 11x, 20 is bigger, so it's negative, and then plus 18. The end. That polynomial has those answers. If you want to check your work, which you're allowed to do, I do this on scratch paper if I were you, but if you want to check your work, if you do synthetic division with those numbers, you should get a remainder of 0, right? So if I, for example, I did 9, this again would be scratch work, this would not be on paper. I got 1, negative 8, negative 11, and 18. Bring my 1 down. 9 times 1 is 9, negative 8 plus 9 is 1. 9 times 1 is 9, negative 11 plus 9 is 2. 9 times 2 is 18. That's not working. Oh, sorry, this would be negative 2. There we go. Pay attention to detail, even me. These are different. I subtract 11 is bigger, so it's negative. 9 times negative is negative 18. Remainder is 0. Check. If I wanted to make sure 1 worked, at this point I got a reduced polynomial. I can just do 1 right here. Bring the 1 down. 1 times 1 is 1. 1 plus 1 is 2. 1 times 2 is 2. Negative 2 plus 2 is 0. Check. And then negative 2 should work. Negative 2 times 1 is negative 2. 2 minus 2 is 0. There you go. Remainder is 0 on all three, so that means all three are the right answer. So again, they're checkable in that scenario. You have all real answers. It's real easy to check. All right, and that's how you do these problems. Again, this is the answer. All I did here was I was checking my answers to make sure they actually worked. I checked to make sure these made remainders of 0 as I reduced the polynomial down.